All right, so we're going to talk about organizing and visualizing data. Let's make sure we're focused in there. All right, we are. Okay, so we're going to talk about statistics, and it is a science of collecting data, organizing data, analyzing data, and making predictions of data. A population is the total set of observations that can be made. They're basically the elements from a set of data. A sample is a subset of the population, so if this big circle is our population, the sample is the small circle. It's just a little subset of it. Biased does not accurately reflect the population as a whole with regard to the data we're gathering. Bias can occur because of how we choose the people who participate in the survey. You could have leading question bias, which is the use of double negatives or not clear questions. Selection bias, that's poor sampling techniques. So for example, if we conduct a phone survey in the middle of a weekday afternoon, we would probably get an overrepresentation of retirees and stay-at-home parents in our sample. Or we might do a call-in survey conducted by a local news show. And radio stations are also prone to selection bias because it's all about who's watching at the time. It's not available to everybody. Data is a collection of information, and data can be qualitative or quantitative. Qualitative data consists of information about characteristics such as eye color or gender. It is descriptive and conceptual, categorized based on traits and characteristics. Measurements that deal with quality. Measures of types may be represented by a name, symbol, or a number code. So qualitative data is about a quality like your eye color or like how something tastes. It's a quality thing. But quantitative data gives a meaningful numerical measurement. How many, how much, how often. And it can be counted, measured, and expressed using numbers, information, and quantities like your height or your shoe size. Frequency distribution determines the count of frequency, or the count or frequency with which each value occurs, or the proportion of time each value occurs. And relative frequency is the number of times the event occurs during experimental trials, divided by all the outcomes. So a frequency table will list the values in the left column and the frequencies and relative frequencies in separate columns. So we're going to use, to help this really become sense to you, we're going to use tables to summarize some TV program evaluations. So assume 25 viewers were surveyed to evaluate a preview of an episode of NCIS. The possible evaluations are E for excellent, A for above average, V for average, B for below average, and P for poor. And we have our list of, this would be the data that came in. And with that data, we're going to make a table. So we're going to have, this will be example 1, and we've got an evaluation and the frequency. Because it tells us that we want to construct a frequency table and a relative frequency table for this list of evaluations. So we only have a few different responses. We have the excellent, the average, the above average, the average, below average, and poor. And then to figure out how many times it occurs, we're going to go over here and look for an E. So I see 1 E, 2 E's, 3 E's, and 4 E's. So that means the frequency is 4 because it occurred 4 times. For the A, it occurred once, twice, 3 times, 4 times 5, 6, and 7. So the frequency is 7. For V, we have 1, 2, 3, 4, 5, 6, 7, and 8. For below average, it's the B. So 1, 2, 3, and 4. And then for poor, we have 1, 2. We have 2 P's. So we're going to put our total down here because you want to make sure it adds up. As I add these up together, I end up with 25. Well, that's the correct number. If when you add it, you don't get to 25, on this particular problem, you'd have an issue because we know there's 25 evaluations. So you can add that to make sure you didn't leave one out, and you can double check. So this would be a frequency table. Now they also asked us to do a relative frequency table. So again, we'll have the evaluation, and this time we'll do the relative frequency. And in a minute, we'll put these together as one. So we still have the E, the A, the V, the B, and the P. And we're still going to look for a total. But now it's a relative frequency. So the E occurred 4 times out of a total of 25. And that will get us a decimal of 0.16. For A, it occurred 7 times out of 25. So that's equal to 0.28. V occurred 8 times out of 25. So that'll get us 0.32. B occurred 4 out of 25, which again is 0.16. And P is 2 out of 25, which gets us 0.08. So this would be the relative frequency, and when we add these numbers, you should get to 1. Now sometimes you might get 1.01, you might get 0.99. Because of the way we round our digits, it might be a little over or a little bit less. So just be aware it could possibly happen there. And there's, if you're in my class, there's the example of the charts we just drew. All right, so let's go on to example 2. So for example 2, we're grouping some data values into classes. Suppose 40 school counselors take a test to evaluate their skill at identifying the signs of depression and earn the following scores. So these are their test scores. We're going to construct a frequency table and a relative frequency table for the data. And this time we're going to put it all into one table. We did 2 separate ones so you could see the difference, but we're going to make one table. Because there's so many different scores in the list, we need to group the scores. We didn't have just 5 outcomes. We have several of them. Our smallest score is the 51, and the highest is the 88 in our group. So we're going to group them where we'll do with a 5-point range of it. And if we take 88 minus 51, we get 37. And that's about 40. So 40 will be the total range, but we're going to do them in groups of 5. And this table can actually help us see the patterns in the data. So here we have the range of scores. And we'll have the frequency. And the relative frequency. All right, so our range of scores, because we know the lowest is 51, we're going to start at 50. So 50 to 54, and then 55 to 59, and 60 to 64, 65 to 69, 70 to 74, and then 75 to 79, and then we have 80 to 84, and 85 to 89. And then we'll have our totals down here. So remember, the frequency should add up to be the total number that we have, of our scores. There were 40 participants, so this should add up to 40. And then this one should always add up to be 1. All right, so the 50 to 54, we're going to look through our data. There's 1, there's 2, and I don't see any other ones. So that would be 2, which makes this 2 out of 40, because we know that there were 40 people who participated. And that'll be 0.05. And then from 55 to 59, there's 1, 2, and 3. So that'll be 3 out of 40, which will get us 0.075. To make our time go, I'm just going to tell you that in 60 to 64, there would be 5 of them. There would be 6 in the 65 to 69. There's 4 in the 70 to 74. There are 9 in the 75 to 79 range. 80 to 84 would be 7. 85 to 89 would be 4. So if you're working on it and you have the information, you could try and see if you can get to it on your own and then come back and see. So here if we add all these up, we do get our total of 40. So now this will be 5 out of 40, which will be 0.125. 6 out of 40 is equal to 0.15. 4 out of 40 is equal to 0.10. 9 out of 40 is 0.225. 7 out of 40 equals 0.175. And 4 out of 40 is again 0.10. And if we add all this together, we do get 1.00. Now, from this data, we can see that the counselors, most of them scored pretty good, but we actually do have 11, 12, 13, 14, 15, 16. 16 of them did not pass. So that might tell us that maybe we need to do some extra training with them, or figure out what we need to do to better help them recognize that sign of depression. So that way we know that they are truly trained. And that's what these data can tell us. All right, and there's a picture of it if you have the handout. So the bar graphs are a way to visualize a frequency distribution for qualitative data. We want to specify classes on the horizontal axis and frequencies on the vertical axis. So for example 3, we are going to draw a bar graph of the viewer evaluation data. So that's the stuff we did a little bit ago. So we'll draw a bar graph of the frequency distribution of the responses, and then we're going to draw a bar graph of the relative frequency distribution of the responses. So we're going to use our information we had right here in example 1. All right, so this will be example 3. We're going to keep that information handy. And so, like I said, we're going to, it said that we would use the classes on the horizontal, the frequencies on the vertical. So let's draw a graph. So this will be our viewer ratings, which are our classes, and these will be the frequency. We're always going to start at 0 if we want our graph to be clear about what it is. And we only go, our highest value is 8, so we need to go up to 8. So 1, 2, 3, 4, 5, 6, 7, and 8. And then we need to put our letters that we have. So we have E, A, V, B, and P. So for the excellent rating, we had 4. So we're going to draw up to the number 4 and go across and make a bar. And I'm going to shade it just a little so it's obvious that it's there. For the above average, we had 7. So we're going to come clear up to this point here. Try to make them the same width. It's not always easy, just depending on how you spaced them. For the average, we had 8. So we're going to come all the way up to here. And then for below average, we had 4. And then for poor, we had 2. Now we're going to do the same thing for, so this was part A. We're going to do the similar thing for part B. We are looking to do the relative frequency. And we're going to actually use the percent. So the percent of this would, let's go up and change it slightly. So if we move the decimal place 2 places, that'll get us 16%. This will get us 28%. This is 32%. This would be 16%. And this would be 8%. So we're going to use a percent on our relative frequency. All right, so we're going to draw another graph. Now on this one, we're again going to start at 0. And we only go up to 32, so let's go in increments of 5. So we would have 5, 10, 15, 20, 25, 30, and 35. So this will be percent. And then this is still our viewer ratings. Alrighty, so for the E, it is at 16%. Oh, let's put our letters down here. We have E, A, V, B, and P. So at 16%, we're going to be a little above 15, not a lot, but a little bit. And for our A, we're at 28%, so right below 30. For V, we are at 32, so we're right above 30. And the main thing as you're doing these, make sure that they're at least relative to each other, so don't have them too close together. And then we're at 16 again. And then we're at 8. So now we've drawn both of the tables for example 3, or the bar graphs. All right, so understand that in example 1, we were talking about qualitative data because a viewer couldn't give a rating between average and excellent. So they could only give certain ones. So this is the quality. And example 2, for our the test, those are actually quantitative. But the scores on the test had whole number values. So we're just kind of clarifying here. This couldn't be any value. It could only be a whole number. But they were actually quantitative because the number actually meant something. You know, if you got something above a 70, you know you passed. Anything below. But here for the viewer ratings, these are more of opinions. Did you like it? Did you not like it? So it's a quality. This is quantitative because you can actually get a quantity on it. All right, so for example 4, we are going to draw a histogram to represent an increase in exam scores. So a professor collected data regarding the increase in test scores by her students after a ban on the use of all social media during class. The data, which includes some fractional values, is organized in the table. We're going to compute the relative frequencies and then use them to draw a histogram. All right, so we have a chart here that tells us our information. We have the points that were gained, we have the frequency, and we have the relative frequency. So it's already organized in our table, and you notice we have a total. We had 65 students that participated, and our relative frequency totaled up to 1. So now we're making a histogram. The difference between a bar graph and a histogram is a bar graph has those separations between them, and then the histogram, they are actually touching each other. All right, so let's go move some of our papers out of the way here. So we're looking at example 4. And we're just doing basically the same thing that we've done, but this time we are doing a histogram instead of the bar graph. All right, so we've got our graph we've got to draw here. And again, we're going to start at 0. And this side, again, is going to be our percent. So for those percentages, again, we're going to move our decimal place 2 places to the right in order to do that. And then down here, we're going to do the number of points gained. Now, we were given 0 to 10, 10 to 20. This is where a histogram makes sense because the values are a range of values from 0 to 10, 10 to 20, and so forth. So we need to go all the way up to 50. So this will make 10. Try to make them even. 20, 30, 40, and 50. And then going up for a percentage, we need to go up to about 40 because we have a 35% that's happening. So I'm going to make like a dash for 5, but then mark it at 10. This would be 15, 20, 25, and 30, 35, and 40. All right, so from 0 to 10, we had 14 of the students were in there, that they gained 10 points, and so it's going to be 21.5%. So we need to go up to 20 and just a little bit above it. So we're going to come up about right here, a little bit above 21, or above 20, and come on up. And then for the second group, from the 10 to 20 points, we are at 35.4, so 35, a little bit more than 35, just barely. So we'll bring this up. Oops, a little over. Try to make them as even as you can. It's hard to draw straight lines without a ruler. The next group from 20 to 30 is 26%. So it's a little more than 25, so we'll be about right here. And then for 40, from 30 to 40, we are at 12%, a little bit more than 12, so about right here. And then from 40 to 50, there was only 4.6, so it's not quite 5. And then let's color in our histogram. So that's similar to the one on your thing. So what we can notice is that the histogram can let us see that just over 35% of the students gain between 10 and 20 points. So that's a really good deal to gain that much. That's pretty cool, just from putting away your phone. So there's maybe a hint. All right, let's go into example 5. So in example 5, we are determining the information from a graph. The histogram shows the number of Atlantic hurricanes over a period of years. And our source is from the Colorado State Tropical Prediction Center. We're going to use the histogram to answer the following questions. So here's a histogram, and we're going to answer some questions. So for example 5, our question is, what was the smallest number of hurricanes in a year during this period? And what is the largest? So the smallest number were 4. This is the number of hurricanes. This is how often it occurred. So the smallest number is 4, and the largest number of hurricanes is 19, which is down here. In one year they had 19. So the part A, the smallest, there were 4, and the largest had 19. What number of hurricanes per year occurred most frequently? Well, this is where we're going to look at our frequency, and the most frequent one is going to be our highest bar, and that's at 11. So for part B, we are at 11. They occurred the most often, and actually this tells us how many years. It was in 10 years. In 10 different years, they had 11 hurricanes. It'll be interesting to see how those continue to go. All right, for part C, it says how many years were the hurricanes counted? So this is where we have to add how many times they occurred, and that's the frequency. So we have, the first one has 1 frequency, this is 6, this is 6, this one would be 9, this one is 4, here we have 6 again, we have 11, 10, because we're looking at the frequency, not the number. This one would be 5, and then 5 again, and here we're at 3, and then we have 0, 0, 0, and then we have 1 and 1. And if we add all those together, we're looking at 58 years, because that's how many years they were counted. Because of the frequencies, we know that each frequency was a year, so a total of 58 years. All right, part D says, in what percentage of the years were there more than 10 hurricanes? Well, if we're looking at 10 or more hurricanes, so 10 or more, we have to take the 10 plus excuse me, allergy season, 10 plus divided by the total, so 10 or more occurring. So if we look at that, we first have to find that total of how many occurred or had 10 or more. So we're going to start with 6. Let's see, was it more than 10 or 10 or more? We're more than 10. So we have to start at the 11. There were 11 that occurred, so that's going to be 10. Plus, we had 5, plus 5, plus 3, plus 1, and then plus 1. Oops, we have too many plus signs. Sorry about that. All right, so that total gets us 25. So we have 25, and the total number of hurricanes that were tracked are going to be 58, or the years. So 25 out of 58 is going to get us 0.431, and that'll be 43.1%, because we're just moving that decimal place 2 places. So that would be our answer for part D. All right, so the next thing we're going to look at are stem and leaf displays. So they represent two sets of data side by side. The left digit is the stem, the right digit is the leaf. So if we have the number 38, that has a stem of 3 and a leaf of 8. So example 6, we're going to use stem and leaf home run records from 2 eras. So the following are the numbers of home runs hit by the home run champions in the National League for the years 75 to 89 and 2001 to 2015, and we want to compare these home run records using a stem and leaf display. So we have part A and part B. So we are going to create the stem and leaf. And so we're going to have 1975 to 1989 on this side. And we'll make our stem. We're actually going to combine the two of them together. And then on the other side, we have from 2001 to 2015. So as we make our stem and leaf, we're looking at the numbers. And we can see from our chart, or our data here, the lowest number is in the 30s. So we'll put a 3. And then we'll have the 40s, the 50s, the 60s, and the 70s, because the 70s is our highest. So now what you have to do is put all the data. You want to go in order of the number that occur. So we have 38, 38. Well, here's a 31, a 37, a 36, a 37, a 37. And a 39. So if you have several of them, you can make a list. So we know that we have a 31, and then we had 36, a 37, a 37, we had another 37, we had 2 38s, and then we have a 39. So we're looking at those numbers. Those numbers, I've kind of put them in order. And so now those will come up here. So 31, 36, 37, 37, 37, 38, 38, and 39. So you got the 30, you're just putting the digits there. All right, so for the 40s, we have, and on this one, I'm just going to kind of finish putting it in numerical order. So we have a 40. We've got 2 48s. Here's another 40. We have a 47 and a 49. So we'll do 48, 48. Oh, we forgot the 47. 47, 48, 48, and then 49. So here we'll have 2 40s, so that's 2 zeros. And then a 47, a 48, a 48, and a 49. All right, so that leaves us with 52. That's all I see on here is a 52. And then that side is done. Over here for our 30s, we have a 39, a 36, and a 37. So 6, 7, oops, no comma needed. 6, 7, and, it's a habit, and 9. 6, 7, and 9, because I'm making them in the order instead of going backwards. All right, so on 40, we have a 49, a 47, a 48, 47, 48, 42, 41, and 42. So we have a 41, we have 2 42s, and then we had a 47 and a 47. So we have 2 47s, and then we had 2 48s, and then we had 1 49. And you could again put them all in numerical order first to make it easier. For the 50s, we have a 51 and we have a 50, and a 58. So 0, 1, and 8. For 60s, we don't have any in the 60s, but we do have a 73. So that's what our stem and leaf would look like. And we can use this to compare the data. We see that the home run champions now hit more than those in the 70s and 80s. We can tell that by we have less 30s, we had more on the 40s, the 50s, and the 70s. So they're hitting more. Now part of that could be the people, and part of that can be the sporting equipment, the different bats that they have, and that kind of thing. So this one is putting it in a combined. You could also draw two separately, so which may be a little bit easier. So you can draw one and then draw the other one and then put it together. But they wanted one that was being able to combine it, so I wanted to show you what one combined would look like. So this would be like one of them. And then if you were putting this one as a single, you would still put it on that side, as shown here. It would still go over here.